Okay, so we've talked a little bit about what the Junos OS software is and how it works. Now let's talk a little bit about the Junos control and forwarding planes. It is important to understand how traffic flows through a Junos device so that you have a basis of understanding on which to troubleshoot them. So let's discuss the functions and operations of the control and forwarding planes on a Junos device. Control is key when we are dealing with a device that passes traffic through our networks. When a Junos device receives a packet or frame, the first thing it needs to do is figure out where that information is going. The control plane is where the device determines what to do with the data coming in. Then it tells the forwarding plane what to do with the data, and the forwarding plane carries out the orders. You can think of it like the control plane is the brains of the operation and the forwarding plane is the muscle. When a packet or frame comes in on an interface, the control plane processes it through the RE, or the routing engine, checking it against the routing table, and then the forwarding table, and comes to a determination on where the packet or frame needs to go based on the device configuration. The control plane then passes the instructions to the forwarding plane, and the instructions are carried out. The packet will either be dropped or passed on to an outgoing interface. The routing engine, in essence, controls and monitors the chassis. It therefore manages the PFE, or Packet Forwarding Engine. Like I said before, the routing engine is in the control plane, and it's the brains of the operation. So it tells the PFE, or Packet Forwarding Engine, what to do, and it resides in the forwarding plane. With Junos devices, the control and forwarding planes are completely separate and independent of each other. This is so that devices can better handle unanticipated loads and can actually pass traffic faster as both planes are running concurrently. What this means to you as an engineer: if for some reason your Junos device starts getting bogged down with large amounts of traffic for one reason or another, or a configuration is implemented that is having unintended consequences, you should always be able to reach the device and make configuration changes. The control plane should not be affected by excess loads in traffic to the point where you can no longer manage the device, as can happen with other manufacturers. Another example would be if you are troubleshooting a device that is in production. A tool that can be very handy in troubleshooting issues is turning on debugging. Some other manufacturers will advise not to turn on debugging on a production device because it can draw a fair amount of processing power. With Junos, because of the separation of the control and forwarding planes, and thereby the separation of the routing engine and the packet forwarding engine, you can turn on debugging, or trace options as it's called in the Junos world, and see all the debugging information in real time while maintaining your packet forwarding rates. This is what the separation is really all about. The control plane is referred to as the intelligence of the platform. The control plane is home to and maintains the routing table, the bridging table, and the primary forwarding table. Keep in mind that the forwarding table only contains active routes, and its primary use is to process transit packets. Also, notice that the routing table exists in the control plane and not in the forwarding plane. Notice also that the forwarding table exists in both the control and forwarding planes. The forwarding table in the control plane is referred to as the primary forwarding table. The forwarding table in the forwarding plane is basically a copy of the one in the control plane. The forwarding plane is ASIC based, as it offers better performance for extremely fast execution of packet forwarding. Just keep in mind that the forwarding plane does all the legwork in moving the packets and frames around. It does what the control plane tells it to, basically. So now we can see a little better how the Junos OS processes traffic and forwards it on. Keeping the control and forwarding planes separate from each other allows for fast traffic forwarding and overall OS stability. We will talk a little bit more about the control and forwarding planes in the next section.